So today we're going to continue on our discussion on systems of equations, and we're going to do our third method for solving systems, and that's called elimination or the linear combination method. And both of those names serve a purpose, and we'll get to why that is in a moment. But let's start with, when do we use elimination or a linear combination method? So we're going to be looking at equations that are in standard form. That means you have x plus y equals the solution. And we're going to be using elimination when the coefficients are other than 1 on all the variables. Yesterday, we talked about using substitution when you have a variable by itself. When you have just an x, just a y, a coefficient of 1, makes it easy to solve for that variable and substitute. Well, now we're going to get into more challenging equations like you see in example 1. Where in example 1, you see the equation 3x minus 4y equals 10 and 2x plus 4y equals 15. Those two equations make up our system of equations. So we're looking for the x and y values that we can plug in to both of those equations and be a solution for both. Well, the reason why it's called the elimination method is because to solve this, we're going to eliminate a variable. And the reason it's called linear combination is because in order to eliminate a variable, we're going to combine these two lines. We're going to add the two lines together. And so if you look here, I have 3x plus 2x gives me 5x. When I add my negative 4y and my 4y together, I get 0, which eliminates that variable, hence the elimination method. And when I add 10 and 15, I get 25. So just like substitution, our goal in substitution was to get to an equation in one variable. We substituted so we would only have one variable. Today we're going to eliminate one of the variables so we can get to an equation in one variable. So we get 5x equals 25 for our new equation. We solve that, giving us x equals 5. Now, just like everything in systems, we're not done. We need to find the y value. X is not the only solution. So in order to do that, we plug in x to one of our original equations. And you see I chose the first one. It makes no difference which one you choose. If you've solved for x correctly, you'll get the same answer plugging into either of the first two equations. So I plugged in 5 for x, giving us 3 times 5 minus 4y equals 10. So that's 15 minus 4y. We subtract the 15 from both sides and we get negative 4y equals negative 5. And when we divide by negative 4, our answer becomes y equals 5/4. Now, a couple of my examples here are going to be fraction answers. What you're going to see on your worksheets, they'll work out to whole numbers, but because I just made these up here off the top of my head, they might not work out as nice. But we're fine getting fraction answers. It's not going to bother anyone. We get this answer then of x equals 5, y equals 5/4, and so again, to connect everything we've done, that means that if we graph these two lines, they would intersect at the point 5, 5/4. So we've got two more examples to look at. Example 2 sets up a little bit of a more challenging problem. When you look at your two equations here, 4x minus 5y equals negative 18 and 2x minus 2y equals negative 11, it's not set up as nicely. We don't have a situation where if we added the lines together, we could cancel out a variable. Because right now, if we added those together, we would end up with 6x minus 7y equals negative 29. And that didn't gain us anything. We would still have a system in two variables. We want to get to an equation in one variable. So what we need to do is we need to look at what could I do to either one of those equations so that I could cancel out a variable. And if you look at your x's there, you see we have a 4x and a 2x. And so therefore, if I wanted to cancel out my x variables, I would need to have a 4x and a negative 4x. So we can use what we know about algebra and say we can manipulate that second equation and turn the 2x into a negative 4x by multiplying by negative 2. Now in algebra, we have all sorts of rules. The largest one being you can change an equation as long as you do the same operation to both sides. So we're going to take that second equation and multiply the entire thing by negative 2. We're going to multiply the left side by negative 2 and the right side by negative 2. So that equation becomes negative 4x plus 4y equals 22. Then I'm going to pull down my top equation here and write my system again. So now we have a new system we're working with. We had manipulated one of the equations so that we would be able to eliminate a variable when we did linear combination. So if I add these two lines together, the x's cancel, I get negative 1y equals 4, So therefore y equals negative 4. And just as before, to get my final solution, I need to plug back into one of my original equations. I chose the top one, 4x minus 5y equals negative 18, substituting negative 4 for y, and we solve, giving us x equals negative 19 halves. Now I'm not going to talk through the solving steps because I know you know how to do those. Alright, our final example here, example 3, puts us in a situation where this is as difficult as we can make a system. We have 2x and 7x, negative 5y and 4y, negative 31 and negative 1. We compare that to our previous problem. Here on our previous problem, we had this 2x and 4x. We could easily make 2 into negative 4 so they would cancel out. In this case, we can't change 2 into 7. We can't change 4 into 5. So what we're going to have to do here is we're going to have to change both into a common multiple, something they share. And so I'm going to choose to work with the x's and eliminate the y's in this problem. And so I look at a negative 5 and a positive 4, and I say I could make that into negative 20 and positive 20 so that my y's would cancel out. So to do that, I multiply the top equation by 4, giving me 8x minus 20 equals negative 124. I multiply the bottom equation by 5, giving me 35x plus 20y equals negative 5. Now I have an elimination situation. 43x equals negative 129 when I add my two lines together, which gives me x equals negative 3. Then I go through my substitution step. I plug into the one of the original equations and solve, giving me y equals 5. Now some of you are probably wondering, you looked at that and you might have said, well, I would rather make 2 and 7 both into 14, and I could multiply the top equation by 7 and the bottom equation by negative 2 and eliminate the x's. And if you did that, you would be exactly correct. You can do either method. You can eliminate either variable first. If you had eliminated x and solved for y, you would have gotten 5 for y right away. Then you would have substituted that in and gotten negative 3 for x. It does not matter which variable you eliminate. Either one will get you to the same solution. All right, good luck, and we'll see you tomorrow.